exponential regression up. And the exponential regression equation looked like this. I'm going to write it over here on this side so it's on the video. But that's what the exponential regression looked like. Remember this problem? Go to your review sheet, number 20. Remember, we figured out when we would have 200 million iPhones, and then with a quadratic model, and then we wrote an exponential model, and we said, okay, in the same number of years, in 6 years, approximately, we would have like 400 million phones. Remember that? Oh, you guys, we were in the middle of that conversation. So anyhow, what I forgot to have you do is, oh crap, I cleared mine out. Read me that over there. What's it say? Y equals?
The
top. Yeah. No, the top.
2.8769 parentheses 2.2663 parentheses x.
Okay, so that was the exponential we came up with. Okay? So if you lost that, the data is still in your calculator, do an exponential regression, and then do a residual plot for that regression. And draw it on your paper. So the data's in, do an exponential regression, and then do the residual plot for that regression. This is what you should get when you do the exponential regression. And then draw your residual plot on one of these things here, labeling it. So you know, okay, this is my exponential plot. Make sure that you are labeling your axes. You should have 1, 2, 3, you should have 6 points. Okay? Now, you're drawing it right here, right? And you're labeling your axes so that if you put a point on the y-axis, I know where it's at. So is that up 1? Is it down 3? Where is that point on the y-axis? And then where is the point where it says 1, 2, 3, and so on? Okay, so you have your, okay, we need your residual plot. Okay, so we go to stat plot, okay, graph, and then probably, what is it, zoom 9? You need to make it fit your stat, which is 6. And then label that one the exponential one, because we gotta do the same thing with our quadratic. We should have done it yesterday, we didn't. My fault. So now you're gonna go back, and you're going to, after you get that plot drawn for your exponential, you're gonna go back and using the same data points, you're just gonna do your quadratic regression. So just go to stat calc, quadratic, get that regression, and then do its residual plot. Guess what we're trying to do here? We're trying to do what we are often tasked to do in this course. We've got a set of data and we have to figure out the best model. Okay, we've done a quadratic model, we've done an exponential model, which one is best? Well, we started that conversation yesterday at the very end of class, but today we're going to finish it. What are you doing? Let's remember, my friend, that there is no such thing as calculator error. User area error is what we have. So let's go to stat error, see what we got. here's the problem. You didn't store your equation. So what we do is, when we do our stats, we go second, stat, out, we got the exponential. We've been through this, pay attention, we're not doing it again. So regression equation as y. And then you can calculate. And then it's gonna put it right there where you want it, the whole thing. And then you're going to do the residual plots, you're gonna go, it's on, for the yes, graph, and then go stat.
Edit. I don't plug in all of my numbers again.
That is the residual plot for the exponential model.
Go down to store.
All right.
One more. There's one more to answer. One.
Looking at the two residuals that you came up with, which do you think is better? The quadratic. Because what's happening in the exponential residual plot? What's happening? Remember, you don't want to be predictable. And it is clearly going down, 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 down. Now, keep in mind what that means, you guys. If the residual plot is doing this, then that means as you go along, your residuals are getting to be bigger and bigger negative numbers. So what does that mean is happening to the data points? Remember, if you're getting more bigger and bigger negative numbers, then aren't your predicted values getting farther off? And isn't that what we observed yesterday? Remember, after 6 years, the quadratic model predicted 200 million. After 6 years, the exponential model predicted 400 million, almost. Right? So if you have to decide, should I use a quadratic or an exponential, what's going to be your decision? Quadratic, absolutely. The exponential might be okay in the first couple years, but eventually, I mean, not after 10 years, it's just off the charts.
Doesn't that kind of look like an upside down exponential?
It does, and that makes perfectly good sense because these exponential values are growing. The model is bad. Okay, so we gotta understand the model's bad. But as the function values keep getting bigger and bigger and bigger and bigger, the residuals keep getting smaller and smaller and smaller at a very fast rate. Very fast rate.
I think it goes back down on the left side because 0 is like below.
Oh, it might, but I'm really not interested in that. I'm interested in what happens as I go out into the future. So remember, we're basing this on 6 data points. I can tell from what I got in my own common sense that they're just gonna keep on going. They're just gonna keep getting farther and farther away from reality. Okay. Perfect. Oh, where am I? Okay, so now I'm ready for 21. Oh, this is one of the tricky ones. Okay, this is the one of the ones where you have to think. So you have, these guys are apparently exponential, because you're gonna write an exponential function. And
What is this?
all right, we gotta figure out A, B, and C. So it's an exponential, but it has a vertical translation attached to it. So what did we do first? We had some of these in our notes, we had one in our homework. What do we do here? First, let's figure out what my base is gonna be. So that difference is 6, and this one's 12, and this one's 24. So what's my base? 2. So I know my equation's gonna be y equals something times 2 to the x plus something. So now we know that we're getting whatever our new y's are. We need to examine some new y's here. But whatever they are, we are timesing by 2. So you have to look at the numbers that you've been given. Not these. Look at the numbers that you've been given. And can you think of an adjustment you might make so that we're getting from term to term by timesing by 2? Add 4. Let's look at it. Let's try it. So 6, 12, oh my gosh. Is that it? We're adding 4. And, oh, be careful. I need a first term.
1.
What?
Is it 1?
Is it 1? I don't know, let's try it. Is it 1? And then this is minus 4 because I gotta get back to my original numbers. Okay, does that equation work? 1 times 2 to the first. Oh, will it work for that?
Wouldn't it be 6?
So the first term, 6. All right, let's try that. 6 times 2 to the first minus 4. Does that work? Wait. I need 6 times 2 to the first minus 4 to give me 2. Does that work? 3? Plug in 1, do you get 2? Plug in 2, do you get 8?
Yep.
Plug in 3. That's enough. This is our last one. Do we get 20?
Yep.
Okay, so I think we've got it. Now, here's the scoop, folks. We need our y-intercept. This is our y-intercept. Is that point my y-intercept? Is this my y-intercept? This would be 1,6. No. So what would my y-intercept be? Well, how did she get from point to point here? She multiplied by 2. So what would the y-intercept be? 3? That's where that 3 came from. All right, there's some thought there. Gotta spend some time thinking. Scary notion. All right, number 22, solve. What's your plan?
Common base.
Yeah. We can get a common base. How about we divide by 7? You want to divide by 7? So 2 to the x minus first equals 4 times 4 to the 3x. Now I want to get a common base, and luckily I can. So I've got 2 to the x minus 1 equals 2 squared times 2 squared to the 3x. Everybody with me? How about a nod? Okay? So 2 to the, so all my bases are the same. So now I can just work with my exponents, but be real careful. What's happening to these? What's happening to that 2 and this 6x right here? You're added. So x minus 1 equals 2 plus 6x. Is that okay with everybody?
Yeah.
These are being multiplied, so the exponents are going to get added. So it looks like 5x equals negative 3. Did you get negative 3/5? This out of here. that look okay? Bennett, you're kind of looking at it. You got it? Okay, how about number 23? We can divide by 3 for sure. And then
You can break it down so that 3 times 3 squared the x plus 7.
so over here, this is 3 to the first times 3 cubed to the x plus 7. What's this? 3 to the negative first to the x minus 4. 1 over is a negative exponent, remember? So what do my exponents look like? Be really careful, make sure you're doing the right operation. This is going to be times, so negative x plus 4. What's happening over here? This is going to be plus, but this is going to be times. So 1 plus 3x plus 21. So it looks like 4x is going to equal, I don't know, I did that in my head, that could be wrong.
I'll fact check.
Huh?
I'll fact check.
Yeah, please fact check me. I made a couple mistakes last year and they were making fun of me. And I said, hey, just wait till you're old. Anybody else get negative 9 halves? Got it? Perfect. If Fred got it, I'm good with it. Moving on. Number 24, 81 to the negative 3/4. Kids, we have got to be able to do this. 81 to the negative 3/4 means 1 over 81. And that means the 4th root cubed. 4th root of 181 cubed, 1 over 27. You can do whatever you want with this. My own personal preference, this is just a personal thing, there's no rule that says this is what you should do, but I like to clean up the inside first before I start doing other stuff. So I'm going to go ahead and cancel here and get 3/4. I'm going to cancel my A's. And I'm going to bring my B to the bottom. Now, I did nothing with this. I focused all my energy right here. Now, at this point, I'm going to flip the whole shebang. And then I'll square it. And that's what I get as an answer. So you can do that in lots of different orders. Doesn't have to be the order I did it, but we should all end up with the same answer. what, I don't know, what do you think here? What do you wanna do here?
Flip the 6, the 1 6 into 6.
Alright, so there's my top, now I'm just focusing, like Alex said, on the bottom, and that's gonna become 6 squared. Which is 36. Okay, now what? Aubrey?
Square root of 36 to the third.
Yep, so the numerator is the square root of 36 cubed, which is 6 cubed, 216. And that's 6 cubed, and that's 6 squared. So I'm gonna cancel and get 6. Okay? So now you tell me, we've got 1.5 review sheets, you got all your papers back, what do we need to look at?
Did you say you were getting our arrangements?
Yep, I'm gonna hand those back to you. You're gonna spend some time with your partner on those, yeah.
Can you do 2 6 5 D?
Oh, 2, 6.
What do you get,
5 D. Okay, wait, what do I need to get to that? Okay, I have, my regression, looks like I'm using just a linear regression for the whole problem. So I have for my, regression, I have 2.2675 plus 0.0779x. Does that look okay? All right, so then it says, according to the unrounded model. So I should be using what's stored in my calculator, but I'm gonna go ahead and just put it in here and see what happens. It's not gonna be that much different, I don't think. So, when was the population 5.78 million? So if I put in that equation, which, if I'd entered the data and stored the equation, it would already be there. I'm gonna put it in. And I want the population to be 5.78 million. And go to my window. Look at my data. And what did you get, Alex?
45,733.
Just a second now. I'm using my rounded off, so I made it slightly off. Yeah, I got 45 point, it's all about 45. You get more than 45, that's what you got?
Yeah.
Okay, and I marked it wrong?
Oh, it's because I put it in, like, I put it as 1995.
No,
instead
it should be 1995.
Oh,
At the beginning of 1995, did I mark that wrong?
yeah.
No, it's right.
Okay.
It's at the beginning of 1995. Yeah, at the very beginning of 1995. Sorry about that. What do you have for the one above it?
For like the residual,
Yeah,
negative 0.0646.
and how did you interpret that?
It overestimated because it was minusing
By
the bit.
0.0646 billion people? Okay. Yeah. Sorry, shouldn't mark that wrong, that was right.
Can we do, letter B of number 3 on homework 2.5?
2.5, number 3, B. Oh, good. This is one of those where you have to flip. So the key here is, Fred, it might involve some trial and error sometimes for some of us, but we just have to make sure in the end, whatever equation we come up with is giving me the right data points. Okay, so whatever I ultimately end up writing, if I plug in 0, I have to get this. If I plug in 1, I have to get this. These are the points I'm generating. Okay, so what's happening? This is a 1.5. Is that right? Yeah. This is a 6. This is a 24. It looks to me like we are multiplying by 4. 4. So whatever I have, I don't know what this is, but this is going to be 4. I don't know what that is. So now I gotta look at my points, and I gotta figure out what I could do to make these all going up by times 4. Anybody see anything? So if we add 3 to them, this would be a 1/2. This would be a 2. This would be an 8. This would be a 32. That looks wonderful to me. So to get the points that are actually multiples, times 4 times 4 times 4, you're going to have to add 3, which means ultimately I'm going to be subtracting 3 to get back to the original numbers. And then what is my initial value? This one's easy, because it's 0.5, yeah. So there it is. Now I can check it, I know that's right, but I'm gonna check, randomly I'm gonna check this point. So if I put in 3, I have 1/2 of 64 minus 3. Well, 1/2 of 64 is 32, minus 3 is 29, so it works. You okay?
Yeah, I'm good.
Okay.
Is there an easier way to find like the -3 or like the differences?
I don't know, easier is a relative word, but you can set up a system of equations, like you knew, we knew that was 4, I mean, you gotta know that. And you can set up a system of equations where you take a couple of your points and plug it in. So for example, I use this point right here, I would put 29 here and 3 here. I don't know A and B. Then I could put 125 here and 4 here
I see.
and do a system of equations. That will always work. Whether that's easier or not is, a matter of opinion, but that'll work. You gotta figure this part out first, though, I think. I'm not sure you can do that without figuring that out. All right, anybody else have a homework question or a quiz question? No? All right, let me go ahead and hand back your last quizzes. And you can sort that out with your partners. All these people are absent. Here's Alex. Alex has a perfect paper, so if you need consultation, he would be one to consult with.
So there's apps you can scroll down to.
Declan also has a perfect paper, so now you have 2 people to consult with.
Did you not?
Yeah,
what's it?
Kate's not here.
What'd you guys do? I had what, 30?
Yeah.
Better than you.
35?
You did.
Oh, yeah. 36. I got minus 6.
The excellent quizzes are yours to keep.
Don't. Hey, no, he's not your dad. Don't. Alright? Dylan tries to be your dad, doesn't he?
Let me see. You did not get it perfect.
How's it feel, buddy?
Mine is 0 on this page. Mine's 3 on this page. What I do wrong?
Oh, I know.
What did you know on the back? Let's see your back. Let me see your back.
So we'll take a little time looking at those. Go consult Declan and Al. Do you have a question?
I used to do that too.
Yeah, no,
The
you
6 rounds were 5.
Thank you. If you're
I know, but you have.
I got a question. So for the we got the same answer. We get -1/8, and I got -1/20.
That should be -1. So whoever that person is. That's what happens when I write too fast.
So you got
Anybody else?
Huh? No, it's I might with the English though. Oh, that's the whole. Three's the whole.
And so did that. And so did
1,
that.
2, 3, 4, 5.
You could take it.
Yeah, I know.
It's saying like this is why. So it's a limit of 5.
It's one class, but the same
You can, but I'm not going back on. But you're free to write on.
Oh, you didn't put the commas different? What did you get for?
Like in terms of like hanging forward,
Yeah, dude. Oh, wait, what other games you got? Oh, I got Tetris, Mario.
Block blast. It's not what we should be talking about.
This game.
Let me see which ones you I'm not trying to go back to class.
Here, like, doing some like babysitting thing, like a nanny. That's my girl. You like that?
Why? Yeah, it's alright.
You did?
Yeah, no, it was.
No, you coach when you start writing a video on your card. No, so you did.
I never done
No,
that.
your homework right now. Okay, what?
Look at my homework.
It's not even right,
Like, bro, what kind of math are you doing?
Actually, I looked at like the science. Two things.
You guys got the same score.
I know.
Did you copy off each other?
I'm not.
Yeah.
Good for you. And then I saw some like thing.
I need to drink water, but I need to drink water, but I need to use the bathroom too. I don't want to go. 'Cause I always have to go to the bathroom and get
You do, I know you do, I know you do. And we're trying to control that.
I know I am. I'm actually trying to. I always have to go to the bathroom in Mrs. Ford's class. Like I've had to go since the start of class.
I won't get anything done.
It's very true.
Sit right here, little Enzo.
I won't get anything done.
All right, I got all my quizzes back.
I'm out
Okay,
there.
we've got, we got a homework question to look at, so Delilah, what was it?
Three,
2.4, 3B. All right, so what are the directions? The directions are, right, with a horizontal translation, no vertical dilation. So 3B, so the original is 1/4, 2x plus 3. Okay, this is a vertical dilation. That's what we need to get rid of. What do we know about 1/4? It's 2 to the negative second. So we're gonna rewrite that as 2 to the negative second times 2 to the x plus 3. And then we'll combine our exponents. How will we combine them? Adding them. So 2 to the x plus 1. So this equation and this equation are exactly the same. If you put them both in your calculator and hit graph, they'd be right on top of each other. This one has a vertical dilation and a horizontal translation. This one has only a horizontal translation, which was the direction. Okay? Couldn't do it, Delilah, if we didn't have a common base here. That's gotta be 2 to a power, or I can't do it. All right, anything else? Annabelle is back there. She's working on one of these other review sheets that I gave you. So why don't we take the rest of the period and have you start practicing? I don't care. I don't care what you work on, either one of those sheets.
What time is this?
I have to actually.
Pack, which one again?
Not on the way.
Yep.
Just ready to my